Now, we will see exactly what is this power flow problem and how we try to solve them. First thing that we have to do is we will have to see what are the different variables which we have. Now, we see that in a power network we have at certain buses loads. Now, these loads are controlled only by consumers and the power system has no control on them. Therefore, these variables are called uncontrolled variables or disturbance variables, whereas generation PG and QG are controlled by the power system operator. Depending on the load on the system, he raises or lowers the generation at different generators. As we will see later, he also tries to optimize the cost, that is, for a given loading condition he tries to find out what should be generation at various bus generating stations, so that the total cost of operation is minimum. That we call as economic dispatch problem. So, he adjusts this generation at various bus bar so that he gets an optimal performance, and therefore, these variables, generation variables PG, QG, are our control variables, whereas the voltage, magnitude and angle at all the bus bars, which basically relates these control variables as well as disturbance variables in the system, is the state variable of the system. In fact, if we know these values of V and delta at all the bus bars in the system, we can find out all the other values, and therefore, we call this V delta, V and delta, that is voltage, magnitude and angle at bus bars, as the state variables. Now, what is the power system problem, power flow problem? The power flow problem is for a given operating condition, that is loads and generation at all the buses, we have to find out the voltage, magnitude and angle at each bus. That is, given the disturbance variables and the control variables, that is, if these are specified, find out what is the state variable. That is, for any given operating condition, any particular time when we have this all the loads and generation known, then what we need is, we need to find out for these generation and load what is the voltage at various bus bars, and once we know this, then we can calculate all the line flows and all the other variables. Now, what is the problem in formulating or solving this equation? Well, one of the problem that we face when trying to formulate this power flow problem is that all generation variables PG and QG at all the bus bars cannot be specified. Why we cannot specify the generation at all the bus bars? The loads are known. We can say that we can give the generation also to satisfy this load. Unfortunately, this is not possible because the losses in the transmission line are not known. They will be known only after we know what are the flows in the transmission lines, and so we know the current flowing in each line, and we can find out the loss taking place in each line. So, unless we know the voltages at all the bus bars, we cannot find out the current flowing in various lines, and therefore, we do not know the losses. So, if we do not know the losses, then we cannot specify all the generation, because the total generation must be equal to the total load plus the transmission losses. So, how do we solve this problem? Well, in power flow problem, what we do is we say that one of the bus bars, normally a large generating bus bar, we do not specify its generation. we say that this bus bar is going to take or absorb all the transmission line losses. So, we specify the generation at all the other generators or generating bus bars except for this one bus bar, and since this bus bar takes the slack, that is the losses in the system, therefore, we call this bus bar as a slack bus bar, and we have one slack bus bar in one system. So, what we do is basically we are choosing a reference bus, that is one bus where we are not specifying the real and reactive power generation. Now, if we do not specify real and reactive power generation at this particular bus bar, then we have to specify some other two variables at this bus bar, and normally the variables that we specify at this bus bar will be the other two, that is the voltage magnitude and its angle. Since the angle have to be specified, we normally will choose an angle equal to 0, and therefore, the voltage angle at all other bus bars will be related to this bus bar's angle. So, this bus bar can be seen as a reference bus bar where both voltage magnitude and angle are known or specified. So, we see that we have different kinds of bus bars in the system. One, we have just now seen we have to specify a slack bus, that is a bus which can take care of the transmission losses. So, we can say that each bus K is classified into one of the following three bus types. One, the swing bus bar or the slack bus bar. This is only one swing, there is only one swing bus which is for convenience numbered bus 1. We can number it, it can be any bus as such, but we will generally use bus 1 as the swing bus. The swing bus is a reference bus for which V1 and delta 1, which we typically 1.0 angles 0 per unit is specified, that is the input data. The power flow program computes P1 and Q1 for this bus, that is the unknown for this bus will be P1 and Q1, that is injections at this bus, because we have not specified the generation at this bus. So, we need to calculate that finally after we have calculated the voltage at all the bus bars. Then other type of bus bar is a load bus bar where both real and reactive power are specified. At this bus bar, what are the unknowns? If we know V and delta at this bus bar, we have all the variables. So, here P and Q are specified, that is injection, real and reactive power injection is specified, and the unknowns at this bus bar are V and delta, voltage magnitude and its phase angle. We have a third type of bus bar which we call as voltage control bus bars. These are generally bus bars where we have generation. At these bus bars, Pk and Vk are specified, that is the real power and the voltage magnitude is specified, and the power flow program or the solution of power flow will provide us the reactive power and the voltage phase angle. Now, these bus bars, as I said, are generally the generator bus bars or switch shunt capacitors or static VAR systems. So, bus bars which have these, they are generally PV bus or voltage control bus. The main reason for this is at these bus bars, since we have reactive power control available, so we try to keep the voltage controlled or the voltage magnitude at some specified value.